Okay, the diagram shows two blocks X and Y of masses m and 2m respectively, placed on a smooth horizontal surface. Okay, if the blocks are accelerated by a force F, what is the force exerted on block X by block Y in terms of F? Okay, so we need to draw free body diagram first, yeah? And we have how many blocks? We have two blocks, right? We have two blocks, means we need two free body diagram. Okay, hold on a second. Okay, we have two blocks, so we need to draw two free body diagram for each of them. So okay, let's do it. Okay, let's do it. So first of all, we look at X. What are the forces acting on X? We have, of course, we have the weight of X, and of course from the surface, it has the normal force. We put this as nx. Don't just put n. Must put nx. Okay, it has this pushing force, and also it has this the force from the block Y, yeah, blocking force. You can say contact force from Y. The block Y is the block Y is blocking the way. The block Y is blocking the way. So we can put this as Fyx. That means Y block X lah. The Y Fy on X. Okay, so these are the forces acting on block X. How about block Y? Block Y is block X pushing on Y. X push on Y. You know, the big force push on X, and then X push on Y. So here we have here we have this one, Fx on Y. Yeah, that means X pushing on Y. Okay, and then we also has the weight of Y, and also it has the normal force from the surface Y. So that's it for block Y. So and then these Fyx and Fxy, both of these are contact force. Yeah, these are what we call the contact force. And they are equal to each other. They are equal to each other but opposite in direction. Yeah, they are equal in each other but opposite direction. Can say like this lah, got negative lah. But never mind, no need to write the negative. I mean they are equal in each other lah, contact force. Yeah. Okay, so let's draw one by one. We have two blocks. We need to draw two free body diagram. Okay, let's draw first. Okay, this is we have block X, and then we have here we put as block Y. Do like this, systematic. Yeah, so on block X we have okay, let's draw out. So we have this block X. Okay, no, we for this one, for free body diagram, only draw point mass. Understand? This one is only using point mass. No need to draw the block. Understand? So only draw the point max. Point. So first of all, you draw the axis. This is the x-axis, and then the y-axis. Okay, and then you have the point mass at the center. Point mass. This is the mass x. Okay, the block X has mass what? Has mass m. Right, mass m there. This mass m. Block Y has 2m. Okay, so on block X, what are the forces acting? I draw already. So we have the the big force there, big force pushing on it. It must going out of the point. Not going in. Don't draw here. Don't draw the F like this. No. Don't be like this. Must draw all the force going out of the point. Understand? Okay, so that's it. So and then we have all this. Let's draw this Fyx. Also draw going to the left, yeah, going out of the point. So this is fyx, okay, fyx, fy on x. This is what it means, fy on x, okay, fy on x. Now, and then it has the weight, the weight x, and it has the normal force x. Oops. No friction, isn't it? No friction because it's smooth. Here it says smooth. Smooth, so no friction. So friction, kinetic friction is 0. No friction from the surface of the table. Okay, and it has, don't forget, it has acceleration lah. Yeah, it has acceleration. Like that. Yeah, accelerate, because this thing will accelerate because no friction, so surely accelerate. No force going in the opposite direction. Okay, and then how about block y? Let's draw out the block y also. Block y, draw the axis first. Draw the axis. Oops, sorry. And then we have the point mass here, and then we have the, just draw. Okay, this one is we have fxy. This is fxy. That means this one is fx on y. Yeah, that means x push y, fx on y. Now block x push y, and then we have, that's it. And then we have this for the weight of the y, and also normal force of y. And then we have the acceleration forward. That's it. And then we can remember the rules according to Newton's second law. We apply this formula. Total for x component is total fx equal to ma, isn't it? But for y component it is 0 lah, because acceleration only in x component. The y component, no acceleration, so 0. So remember about the rules, yeah, back in the days I told you. Okay, if same direction, if the direction, yeah, talking about the direction, if same with a, then the force is then the force we put positive. Understand? If opposite the acceleration, we put f negative. Okay, f negative. But if for y, no, it doesn't have acceleration, right? It doesn't have acceleration, so we just follow the same thing lah. We just follow like the usual one, yeah, usual one. So let's say going to the right is positive, going left negative. But this one is about y component, so so no need to regard about the x component. So going up is positive, going down negative, yeah, because we don't have acceleration. So we just follow this lah. So for fy, going up is positive, going down negative. That's it. Okay, but if we have acceleration, we need to compare with acceleration. Same direction with acceleration, f is positive. Opposite the acceleration, the f is negative. Okay, so back to the business. Yeah, back to business. Now I think this one, I think just do the x component enough, because the y component no point doing them. Yeah, the y component no point doing them. But yeah, of course it has the two. Yeah, it has x and y for both. We have x and y. Yeah, if you really want to do everything, I do for you also. So this is total fx equal to ma. This one is the y component is 0 lah. Total fy is 0. Okay. Okay, so if you want to do this also, okay, look at the fx. In x component we have So which one is positive? Follow the acceleration is positive. Opposite acceleration is negative. So this one also follow direction is positive. This one negative lah. Follow acceleration positive. Opposite negative. Follow acceleration positive. Opposite negative. That's all. So okay. So F is positive because for same direction with acceleration. So that is positive. But the Fyx is negative because opposite the acceleration. So negative Fyx. So this one is block X, isn't it? Block X. So this one is using mass of X. Mass of X. So mass of X is just M. So just put M lah. Just put M. Just put M. Okay. And then for Y component, you can just take going up. Going up is positive, going down negative lah. Because no acceleration to compare, you just take going up positive, going down negative. So this one become nx my negative wx, so it's 0. So we can say nx is wx. But we no need the y component, right? No need the y component for this case. Okay, block y. Block y, this one fxy is same direction with acceleration, so it's positive. So that one is positive. Fxy is positive. And then this one is mass y, right? We are talking about mass y. So this one should be using, if mass y is 2m. 2m, so 2m. Put 2m. Acceleration is acceleration. This acceleration and this acceleration should be the same because they are sticking to each other, right? So acceleration should be the same. So just put a lah. Just put a. Okay. And then the y component. Y component just take going up positive, going down negative. Yeah. No acceleration to compare. Just take going up positive, going down negative. Okay, like this, like what I'm saying here. Okay, this one. If you got acceleration, need to compare with acceleration, same direction, acceleration positive, opposite acceleration negative. That's all. Yeah. Okay, so okay, this one is ny minus the wy. So this one nothing lah, because we are not going to use y component. There's no friction to consider. There's no friction to consider, so we no need to find about the normal force. Okay, so we can ignore. Actually, we can ignore the y component. Just focus on the x component. Okay, so look at this one. So how going to do this? We want to find what is the force exerted. What is mean by this? Force exerted. Force exerted on block X. Force exerted on block X. Yeah, on who? On X by Y. That means this is what? What force exerted on block X by block Y? On X by Y. On X lah, Fyx lah. This means what? Fyx. Force Y on X. This is force by Y on X, isn't it? Force exerted on block X by Y. By Y. Yeah. So force by Y on X. So this is actually Fyx. Okay. By Y on X. So we're going to find Fyx. So actually Fyx also equal to Fxy because they are contact force, they are action reaction force, they are equal in magnitude but opposite direction. So if you find Fxy, you also got the Fyx, same value. Understand? So it actually also equal to Fxy. Yeah, also equal. So okay, so let's do it. Yeah, we want to find this. Yeah, actually we want to find this value. Fyx, yeah, Fy on X, F by Y on X, F by Y on X. So we're going to combine these two formula. So do we have any? That no more. We only have F. Okay, so how going to do this? We have two formula here. So we can say these two is the same. You know that? These two is the same. This one and this one is the same. The same. Yeah. So we can say we can put as though fyx is actually the same as fxy. So okay, so we have two formula here. We have f negative, oops, what is happening? Fyx equal to ma, and then we have another formula fxy equal to 2ma. So we have two formulas here, 1 and 2. How going to find the fyx? Very simple, just plus together, isn't it? Just plus together, So that means we f1 plus 2. So what happened is when they plus together, these two, because they are equal, right? They are equal, so they cancel each other, right? They cancel each other. So we got the answer is here is the left hand side is just f. Here we have 3ma. 3ma. So what's happening? So okay, so we got the acceleration is f over 3m. Am I? Okay, we got the acceleration already. We got the acceleration. Now we need to find the fyx. Yeah. So maybe we start with number 2 lah. Number 2 fxy. It is also fyxy. Yeah. It is equal to 2ma, right? So just put in the a there. The a there is f over 3m. So okay, we cancel. It is is 2 over 3f. Okay, 2 over 3f. And this fxy, this is fxy, right? Fxy, it is the same as fyx because they are action, reaction, force. They are action, reaction, force. Okay, so that's the answer. That's the answer. 2 over 3f. Yeah. We find fxy. We also find the fyx. Yeah, because they are the same. They are action, reaction, force. So we got the acceleration first. We got the acceleration, then we substitute into the acceleration. And we got the fxy. Fxy also equal to fyx. So the question asks for fyx. It is equal to 2 over 3f. The answer is 2 over 3f. Is there an answer? Yes, 2f over 3 lah. Yeah, that's the answer. B. Okay, simple. Yeah, that's it. Okay, is 2f over 3 lah. Yeah, 2f over 3. 2f over 3. That's it. Okay, very simple. Hope you understand. Yeah. Okay, that's the questions. Okay, bye bye.